All right, guys, so welcome back. And next chapter, we're moving on. So enough of the triangles, but they'll come back. So we're going to look at chapter 7, quadrilaterals. So just as a general thing, right, a quadrilateral is a four-sided figure. So quad, remember that means four, right? Lateral means sides, right? So four-sided polygon. So that's what a quadrilateral is. So our first section in the quadrilaterals chapter is really not so much about quadrilaterals, but about polygons in general and their angles. So we've got two main theorems we want to look at. The polygon interior angle sum theorem and the polygon exterior angle sum theorem. So the polygon interior angle sum theorem. So a few things you want to remember. Remember, a polygon is a two-dimensional closed shape. And then also remember that the sum of the interior angles of a triangle add to 180. So with those facts in mind, let's take a look. So if we wanted to find the interior angles of a polygon, what we would do is we would break it up into different triangles by drawing what we call diagonals. So diagonals go from one vertex of a polygon to another, and they don't cross. So in this picture, you see a pentagon, right? And there's two diagonals there, okay? And so we can only draw two diagonals, right? Because if I try and draw a diagonal from here to here, right, diagonals would cross. That's not allowed. And, okay. Oh, there we go. Right. So I can't draw a diagonal here to here, right? That would, again, cause diagonals to cross each other. So if you notice, there's 1, 2, 3 triangles, right? So 3 triangles times 180 degrees per triangle means that a pentagon, the interior angles add up to 540 degrees. So again, that would be 3 triangles at 180 degrees apiece, which is 540 degrees. So that's the interior angles of a pentagon. So let's look at a quadrilateral, right? So again, you can start at any vertex and draw a diagonal. So I'm going to start at the bottom left, draw up to the bottom right. So that's actually the only diagonal I can draw, right? Because I cannot draw one to those diagonals because, again, they cross. So we can't have any diagonals crossing. So we're going to have 1, 2 triangles, right? So again, 2 times 180 is 360 degrees. So the sum of the interior angles of a quadrilateral is 360 degrees. Okay, so now this next one, we're looking at a hexagon. Okay, so we want to find the sum of the interior angles. So we just start drawing diagonals. So it doesn't matter where you start. Maybe you want to start at the top. So maybe I'll draw 1 straight down. Sorry, that's not very good. I'll draw 1 straight across. And I'll draw 1 over here. So I have 1, 2, 3, 4 triangles. 4 triangles at 180 a clip. 720 degrees. So we have 720 degrees are the sum of the interior angles of a hexagon. So that's a way to use diagonals to prove it. But what if we wanted to make it a little easier? Well, we'll see in a minute what that would look like. Okay, so in the meantime, just familiarize yourself with the names of all the different polygons. So if you look in the table on the right, we have probably most of these you know: triangle, quadrilateral, pentagon, hexagon, octagon, nonagon, decagon, Some of the weird ones, right? Heptagon, hendecagon, and dodecagon. Those will be new to you. But these are just the names of the polygons with a different number of sides, right? So 9-sided figure polygon is a nonagon, 10-sided is a decagon, right? Decade, non, usually goes along with 9. But anything after 12, we're just going to put a number and then the suffix gon, okay? So a 30-sided figure is a 30gon, a 40-sided figure is a 40gon, a 50-sided figure would be a 50gon, right? But these you'll have to know. You have to remember which sides, which names go along with which sides. Okay. So if you want a theorem to find the interior angles, the sum of the interior angles pretty easily, we're going to use this theorem here, the polygon interior angle sum theorem. So it just says that the sum of the interior angle measures of any polygon is s equals n minus 2 times 180, where s is the sum, right? N is the number of sides. Okay. So this is a formula to show what we did earlier was true, right? So let's go back, right? If we use the formula n minus 2 times 180, that's the sum. So now we're going to plug in the sum is what we're trying to find, right? A hexagon has 6 sides. We do 6 minus 2 times 180. We get 4 times 180, and that gives us the sum is 720. And that's the same thing we got here. So you could draw diagonals, or you could use this formula right here. That's a bit easier to use to find the sum of the interior angles of a polygon. So again, if we try it up here, if we use the quadrilateral again, right, let's use the formula, n minus 2 times 180. The sum equals 4 minus 2 times 180. 2 times 180, and we get 360, which is the same answer we got by drawing the diagonal. So, you don't want to have to draw diagonals every time, but that's where we get the formula from. That's where it comes from, and that's why it makes sense, right? We have a formula, but we have a way to do it, right? Diagonals, in case you don't know the formula or don't understand or forget it. But I think the formula is pretty easy to remember. Okay. So again, our goal was to find the sum of the interior angles of polygons. So how does this shake out in a problem, right? Where you're given a picture? Well, it works out the same way. So we look at this picture over on the right. We have 60 degrees, x degrees, x degrees, and x degrees. So we're trying to find x. But the problem is, right, we don't know what the interior, all these angles, 60, x, and x, are interior angles, right? So we need to know, or one way we can figure this out is to find the sum of all the interior angles, okay? Add all these guys up and set it equal to that number. So, for example, I know that this is a 4-sided figure, right? I have one side, 2, 3, 4 sides, right? The number of angles. So again, I got a quadrilateral, right? So I know the sum is 4 minus 2 times 180. Go ahead and write the formula out first. The sum is 2 times 180. And the sum is 360, right? So the sum of all these angles is 360. So I know that the sum is 360, but I also know all the angles are 60 plus x plus x plus x, right? So the total measure of all the angles is 360, and the interior angles are 60, x, and x. So I just set those equal to each other. I get 360 equals 60 plus 3x Subtract 60 from both sides. 300 equals 3x. Divide by 3, and I get 100 equals x. And that's my final answer. Okay. Now, example 2. Find x again. So now, again, I have interior angles, and again, I want to know what x is, so I can use, right, the polygon interior angle sum theorem. So this is a 5-sided figure. So the sum of the interior angles is 540. But again, I also know that 540 is equal to all this stuff added up, right? So I've got 2x, 2x, 3x, and 3x. So that's 10x. Then I have 14 and 14 is 28, 142. That makes 170. If my math is correct, I think that's right. So now I subtract 170 from both sides. I get 370 equals 10x. Divide by 10, I get 37 equals x. So again, the main idea is you add up all the angles and set it equal to the sum of all the angles inside the triangle. Sorry, inside the polygon, not triangle. Okay. And yeah, so of course I made a mistake in the math when I was doing it for the answer key. So there you go. Go back and fix that. Okay. All right, so again, you can even do crazier stuff, right? You can do six-sided figures, right? I'll leave this one up to you to solve. But the answer will be right there. So hopefully you got the right answer. If you didn't, that's fine. You're just starting out. So, okay. All right. Next thing we want to look at is regular polygons. So a regular polygon is a polygon that is equiangular and equilateral, and an irregular polygon is not regular. So basically, right, regular polygons have all sides congruent to each other and all angles are congruent to each other, but a irregular polygon does not. So if we look at this example, is this a regular polygon? Well, let's take a look. All the sides are the same, so that's check. Number 1. Okay, so it's equilateral. All the angles are the same. They're all 90. So it's equiangular. So is this a regular polygon? Yes, because it is equilateral and equiangular. Okay. Look at this next one. Is this a regular polygon? Well, I think it's pretty easy to see that no, right, since it is not equilateral. This side down at the bottom, right, is not the same as all the other ones. So it can't be regular because it's not equilateral. So you could say it's not equilateral or it's not equiangular too, right? All the angles aren't congruent. But one of those would be suffice to make it not regular. Okay. Okay. All right, our last type of example would be this. Find one interior angle of a regular decagon. So if you want to find one angle of something, just think, right? All the angles are the same. But we only want to find one angle. So first we need to find the sum of all the angles, right? So the sum in a decagon, we use our formula, n minus 2 times 180. So the sum would be 8 times 180. So the sum would be 1,440. So this is the total, right, of all the angles in a decagon. But it's regular, so all the angles are the same. So I have a total of, so the measure of one angle is 1,440 divided by 10, right, because there are 10 angles and they're all the same. So they would equal to 144 degrees apiece. Okay, now give this one a try. Find one interior angle of a regular octagon. So again, we need the sum. So the sum of all the angles in an octagon is 1080, but it's regular, so all the angles are the same. So we'll just do 1080 divided by 8. And you get, I'm going to cheat and look down at 135. Good. Okay, so I had the answer down there, so I'm going to cheat on that one. Okay. So, again, you can do these with pictures also, right? Find the measure of an interior angle of this polygon. Well, if we look at this polygon, right, we know that it's regular. All the angles are the same. So there are 6 angles and they're all the same. So we have to figure out one measure of the measure of one of them. Well, we do the same thing we just did above, right? We take the sum. So the sum is 720, right? We divide that by the number of angles, which is 6, and we get 120 degrees apiece. Okay, and again, I'm going to give you this one to do. So we want to find the measure of one interior angle. So again, we have 1, 2, 3, 4, 5, 6, 7 angles. So again, we're going to find the sum, 7 minus 2 times 180. The sum is 5 times 180. So the sum is 900. And if we want one angle, we do 900 divided by 7. And we get 128.6. So again, if you want to find one angle, you take the sum of all the angles, divide it by how many angles there are, and because they're all the same, right, it will spit out one of the angles. Okay. All right, so we're going to call that a day for that one. We'll pick this up on Monday, and we'll pick up with the polygon exterior angle sum theorem, which is actually much easier. Yeah, so I hope you guys have a blessed day. Enjoy the snow. This is when I'm making it during the snow or ice or whatever you're getting. So, but anyways, I'll talk to you guys later.